The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, or good morning, good evening, depending on where you are. That'll sound just about right. Folks, thanks for logging in early and getting settled in. I really appreciate it. This is Don Cook over at 7 Signal. We're going to get started in about 3 minutes or so here. We've got 10:58 actually, local time. So we'll get going on time. For those of you who haven't been in our webinars before, if you don't mind chatting your location with me today, with Jim and I, and letting us know where you're dialing in from. Love to hear where you are in the world. I am at 7 Signal headquarters in Cleveland, Ohio. And Jim, I haven't asked you yet, but I assume you're in Cincinnati today?
I'm in Cincinnati. I'm not on the road.
And I assume your weather is similar to ours up in Cleveland. Little overcast sky, about 30 degrees today.
Yep, pretty much. There's your standard Ohio winter gray and gloom.
I assume we're not alone in that. So I got some responses here. Harry in the Netherlands, welcome. We've got Independence from Dave. Thank you. Welcome. I see San Francisco, Philadelphia. Awesome. Our friends over in the UK, Open Reality are on. Net Peppers in Germany. Welcome, gang. Got New York. We've got a Miami, Mexico, Texas. Welcome, Chris. All right, very cool. Very well-rounded group today. Keep coming in. We've got North Carolina, Vancouver. Very cool. Thanks for joining us, folks. We're going to get going here in about a minute. We've got a really cool topic today, a new one for us. I'm sure you're really excited about. We got a lot of great registrations for this one. We really appreciate you guys taking time out of your days, you guys and girls, I should say, out of your days to join us on Wednesday mornings. We love doing these, bringing this content to you each week, and we're going to continue to do it. So without any further ado, let's go ahead and get started. Jim, we've got a really fun topic, as I mentioned today. Understanding Bluetooth low energy, cellular and Zigbee. And with me today is Mr. Jim Vajda. For those of you who aren't familiar with Jim, Jim, why don't you give us a little bit of background about yourself and why they should pay attention today?
Yeah, thanks, Don. So I'm our Director of Global Wi-Fi Solutions at 7 Signal, which means I mostly serve as a sales engineer. I'm a CWNE and Cisco CCNP wireless. And before coming to 7 Signal, I was a wireless network engineer with design experience in healthcare, public schools, higher ed, MSP, etc. So broad range of experience with a lot of different vendors. And my Twitter handle is there at Jim Vajda, where I tweet about Wi-Fi and what I had for lunch, things like that. It's very exciting.
And
my blog,
your bike rides and the pictures you take. Very cool.
Yeah, sometimes, although most of that goes to Strava now, so I spare most of my non-cycling friends for my cycling stuff. But I do have a blog, framebyframewifi.net, that's entirely Wi-Fi content if you're only interested in that. So that's me.
Very nice. And for those of you attending WLPC next week, you will be there as well, correct?
That is correct. I'll be there with our CTO, Russ Wengler, and we have a vendor event one of the evenings. Is that Wednesday evening, Don?
It is Wednesday evenings at 7:30.
Yep, open to everyone. So come see what we're doing and help us plan our future, and it'll be good.
Open to everyone in the open bar. Sorry about that, Jim. Didn't mean to talk over you there.
No problem.
Yeah, no. So thanks for the background. We'll go ahead and get started here. I always kick off these webinars with just a little bit about 7 Signal, the right amount, just 3 slides or so for those of you who are not familiar with 7Signal, and then we'll get into the content here. 7Signal was established in 2007. We crunch a lot of numbers. We're monitoring over 5 million devices on a daily basis. And when you take into account all the KPIs that we're measuring across all of our customer networks, we're crunching over 1 billion data points on a daily basis. Over 200 customers. We're really proud of our 13 patents. This last one just coming last week for our Mobileye products. So what you see from 7Signal on the product side, you're only going to see from us. We bring real innovation to wireless network monitoring. We're certified in over 40 countries around the world. We take privacy very, very seriously, and that includes our GDPR compliance for our EU customers, and really excited about that and adding that privacy metric. So 7Signal is here to enable the wireless world, and what we do is we find and fix Wi-Fi issues. Since 2007, we've created an outside-in enterprise framework that's completely AP and device agnostic and modular. So depending on the challenges that you're encountering with your network, or in some cases with our MSP customers, their customer network, all of our products are replete with reports and analytics, as you would expect. And what we're doing is we're looking for the top 7 Wi-Fi problems. Everything that goes on in the world of Wi-Fi bubbles up to one of these 7 problems, and that congestion and coverage, co-channel and radio interference, network services, roaming, adapters and drivers, wireless LAN configuration. Everything, again, in the world of Wi-Fi bubbles up to one of those issues, and that's what we're looking for. And what we're doing is we're running active and passive tests on the network and on the devices for things like packet loss, latency and jitter and throughput, MOS scores, again, looking at those adapters and drivers, giving you a full spectrum analysis, looking at frequency and co-channel interference. Very, very cool stuff. So it's important for you to understand what the difference between an outside-in, which is 7Signal, versus that legacy approach, where if you're not a 7Signal customer, you're still enjoying some great information from your vendors, whether that's from the device manufacturer or your AP vendor. They're able to tell you some really good things. You've got top talkers and some other great information, but they're not giving you visibility into the end user experience, which is our specialty. 7Signal lives on the edge, on those devices, monitoring the air from the access point to the endpoint, giving you really great root cause information so you can get right to the bottom of Wi-Fi issues, whether those issues are indeed Wi-Fi or network related or device related. And because we go back in time up to 90 days, there's no more sorry, I don't see the problem. You can go look at that device, at that network, at that given time when the issue occurred, and get right down to the nitty gritty and get actionable information on how to fix those issues. So really, really cool stuff from 7Signal. 2 modules, I'll break them down really quickly here. Mobileye on the left, that is our app or agent that lives on the device itself, looking for things like adapter driver combinations, roaming issues, adjacent and co-channel interference, coverage and congestion. It's 100% software based, and again, that lives on the device. Sapphire Eye is our perfect client. This is a hardware sensor powered by software that lives up in the rafters with the access points or down on a desk or on a wall. And it's giving you that full spectrum analysis. So it's looking for things like network services, WLAN configuration, radio frequency and co-channel interference, coverage and congestion. So as you can see in these green boxes, there's 3 different problems that these 2 solutions are solving, depending again on your network issues. So with that said, try and keep that brief. Jim, let's go on with the show and give these folks what they've been waiting for.
Sounds good. Thanks, Don. So, we're going to talk about some licensed technologies and some unlicensed technologies. We're going to focus on Bluetooth, Zigbee, and LTE, cellular technologies. And, one of the most important takeaways, because we're going to talk about these at a high level, one of the most important takeaways is understanding what spectrum each of these technologies operates in. So you can see Zigbee there, it can operate in the 900 or 800 megahertz unlicensed band and the 2.4 gigahertz band. And, most enterprises already have Wi-Fi operating in the 2.4 gigahertz band. So if you're considering running Zigbee, you have a spectrum sharing issue to work out. And if you could, which you probably can't, but if you could, you'd be better off perhaps using the 900 megahertz band for Zigbee if you could. And so you can see the other technologies here as well. Bluetooth is in the 2.4 gigahertz band. That's the only band it operates in. But Bluetooth 1.2 and above has a feature called adaptive frequency hopping, where it tries its best to avoid active Wi-Fi transmissions. So it tries to avoid interfering with Wi-Fi. But, again, in most enterprises, you're using the whole band for Wi-Fi, 1.6, channels 1, 6, and 11, and there isn't much space left over for Bluetooth. So, those things have their limitations. And other technologies, we'll talk about LTE particularly here, don't get along with Wi-Fi very well. We'll get into that specifically, but some things really will interfere and cause serious problems for the operations of other technologies operating in the same spectrum, and you really want to keep those separate as much as possible. But this also isn't exhaustive. So we're looking at different wireless protocols here. I put some of the ones that come to mind as, to me, as being the most popular, perhaps gaining the most traction, but there's a lot more unlicensed spectrum technologies than what we've got here. And these are also the US bands and other areas. You might have access to other spectrum as well. So let's talk about the licensed spectrum technologies that you might encounter in the enterprise. Cellular technologies are what we're talking about here, and these are labeled by their generation. So 2G through 5G. 1G was the analog version of cellular, so we can ignore that. And these are usually operated by cellular carriers in big outdoor networks. Sometimes it'll come indoors with a cellular DAS, and we'll talk about that a little bit. Occasionally, with really massive companies like in the oil and gas industry, in mining and power generation, just massive companies that have huge outdoor wireless networking needs, they might run their own private cellular network using licensed spectrum. But to do that, they need a lot of in-house expertise, and they have to be able to absorb the licensing costs and deal with federal regulators, and so it's limited users there. Cellular is named by the generations it was used with, and I've got the standards, the most common standards associated with each generation. I think we'll do a quiz with Don at the end and see if he can tell us what all these acronyms mean.
Oh, great.
No, but what's interesting here is back in the 2G and 3G days, we had these competing standards that weren't compatible. So you could buy a GSM phone in the US and use it with AT&T and T-Mobile, or you could buy a phone with a CDMA radio and use it with Verizon and Sprint. And you couldn't switch carriers without replacing your phone because the technologies were incompatible. And when 4G came out with LTE, long-term evolution, that's when all the carriers decided, okay, enough of this. Let's just pick the best technology and we'll all use it. And that's why, along with some regulatory changes, now you're able to buy a phone, an unlocked phone, and take it to whatever carrier you want. in the US because the radio technology is the same. And we also have number portability, which is something, for the lawyers finally figured out. And so with 4G, we standardize on LTE as the technology standard that is considered 4G. And with 5G, we settled on 5G. So the technology that underlies the 5G generation of cellular technology is called 5GNR. That stands for New Radio. So things are getting simpler in terms of at least the naming conventions that we're using. And if you want to learn more about licensed cellular technology, the 3GPP group is responsible for many of these standards, not all of them, but GSM and LTE and 5G are all we're all driven by 3GPP. So you can check out their website and see what they're up to. So something to be aware of, licensed cellular uses different spectrum than unlicensed technology, which for the most part is perfectly fine. But there are challenges sometimes where a cellular DAS or base stations operating close to Wi-Fi APs can cause interference. This is something we actually detected with our Sapphire Eyes in one of our customers' sites. So this is where a 3G indoor base station with a very loud signal, because it was indoors and close to other APs, were generating these ghost signals or third order harmonic distortion products that were actually interfering with the Wi-Fi AP's receiver circuitry. And this was occurring in the 2.4 gigahertz band. And so actually you find that certain AP models will come with special circuitry that filters off-band cellular signals. So if you have cellular base stations, if you have a cellular DAS operating in your enterprise, it's worth checking out to see if your Wi-Fi APs have that filtering built in and aren't affected by problems such as this. So let's move on to unlicensed spectrum technology. This is stuff that you're probably responsible for. Certainly Wi-Fi is what you're responsible for, most of us, and other things that are happening as well that are gaining traction. So we're going to talk about Bluetooth, Zigbee, and cellular, but there's a whole lot more, particularly low power IoT protocols. I mean, there's more of those than I can just remember off the top of my head. And so, there's going to be some winners and losers in that space, and we'll kind of wait and see how all that shakes out. But there's certainly a lot of interest and activity there. Bluetooth. So Bluetooth has been around for a while. It's extremely pervasive because everybody's smartphone has a Bluetooth radio, and it's used to connect smart watches and earbuds and headsets and keyboards and mice and printers and barcode scanners and now a whole host of IoT devices thanks to Bluetooth Low Energy. So Bluetooth Low Energy was introduced in Bluetooth 4, and it's really just a very simplified version of Bluetooth that uses very little power. So that makes it attractive to IoT. So now, so it's used in IoT networks. It's used in personal area networks. I've got a bicycle with speed and cadence sensors and a power meter and connectivity between the bike computer and my my Android phone and a heart rate monitor, and all of that happens over Bluetooth Bluetooth Low Energy in particular. So the batteries last for 6 months and I don't have to worry about it. So we're seeing a big explosion of that. It uses the 2.4 gigahertz band like we talked about before, although it doesn't sit on a single channel like Wi-Fi does. It's a frequency hopping spread spectrum technology. So it hops from very quickly from across the entire band on these small 2 megahertz wide channels. And it tries to avoid active Wi-Fi, like we mentioned before. But of course, you know, if you've got really busy APs on channels 1, 6, and 11, and there's Bluetooth data transferring going on, some amount of interference is unavoidable. If you want to learn more about Bluetooth, the Bluetooth SIG, I think that's the special interest group, has a website, bluetooth.com, where you can learn all about what they're doing and upcoming standards and features as well. So we talked about them operating in the 2.4 gigahertz band, and this is a view of what it looks like in the spectrum analyzer from our Sapphire Eye. So on the line graph, you see this sort of classic sawtooth or comb appearance with those small spikes 2 megahertz apart. And that's Bluetooth. And you can see there's also an AP there on channel 1. Then on the right, you can see a spectrogram that's got historical data, and you see kind of that washboardy appearance to it. That's, you know, a classic appearance of Bluetooth. And also we've got highlighted there the Bluetooth low energy advertising channels. Just these 3 2 megahertz channels that BLE devices are sort of beaconing on and making other BLE devices aware of their presence. So even when there isn't data transfer going on, they're beaconing there and advertising their services and capabilities. And I'll also mention our Sapphire Eye customers. You know, when you look at their spectrum analysis, it's I'd say the vast majority of the time there is Bluetooth going on in the 2.4 gigahertz band because of all those devices that people bring along with them or have deployed in the enterprise for business applications. It's there, and it's one of the things that Wi-Fi is competing with in that band. So let's talk about Zigbee. So Zigbee is, I wouldn't say it's newer, but it's gained popularity more lately for IoT. And that's because it's very low cost. It's kind of an IoT native protocol. And the battery life, it tends to be superior to other IoT technologies. So that's made it very appealing in the IoT space. Its PHY and MAC are defined in the 802.15.4 standard, which you can look up from the IEEE. And then the Zigbee Alliance, which is their equivalent of the Wi-Fi Alliance for Wi-Fi, builds an application spec on top of that for building IoT applications using Zigbee. There are actually other technologies based on 802.15.4 that aren't Zigbee, but Zigbee seems to be gaining ground. It can use the 800 megahertz unlicensed band in Europe and the 900 megahertz unlicensed band in North America, as well as the 2.4 gigahertz band worldwide. And so what you see is that most Zigbee manufacturers just support the 2.4 gigahertz band because they want to build one device with one radio and sell it globally. So it's much more common to find Zigbee in the 2.4 gigahertz band than the other bands. It uses direct sequence spread spectrum, just like Wi-Fi, so it sits on one channel and it doesn't frequency hop like Bluetooth. And it has 16 channels in the 2.4 gigahertz band that are spread 3 megahertz or 5 megahertz apart and they're 3 megahertz wide. If you want to learn more about Zigbee, go to the zigbeealliance.org. So we talked about it operating in the 2.4 gigahertz band, where Wi-Fi and Bluetooth and a whole host of other things operate. And so if you are looking at deploying a Zigbee solution, you wanna carefully choose your channel plan, because you can see here's a look at the 2.4 gigahertz band, and there's our 3 non-overlapping Wi-Fi channels. They're 20 megahertz wide, so those 3 channels use the majority of the spectrum in Wi-Fi. And then the graph below has the Zigbee channels, the smaller Zigbee channels superimposed above it. And you can see that, there's a couple places you can kind of fit in a Zigbee network without causing too much of a problem with Wi-Fi. So there's still, the shoulders of the spectral masks that can cause adjacent channel interference if they're nearby. But if you can put your Zigbee stuff out on channel 26 and leave the rest of the band for Wi-Fi, you should be pretty good for the most part. So this is what Zigbee looks like in our Sapphire Eye spectrum analyzer. So again, we've got Wi-Fi here, we've got Bluetooth here, and then we've got Zigbee there in the area that's highlighted operating, and those are Zigbee channels 19 and 20. And you can see that that particular Zigbee network is just stepping all over Wi-Fi channel 6. So any clients and APs in Wi-Fi that are operating on channel 6 are having a bad experience because of that Zigbee operation in the same spectrum. Out to the right, you can see, looks like those upper channels, 25, 26, into the Zigbee world are unused. So if we could move that, the operating channel for that network out, things might go a little bit easier. So that's Zigbee. So let's talk about cellular in the enterprise. There's been a lot of different flavors of that that operate in unlicensed and licensed spectrum, and we'll talk about some of those. So the first is probably the DAS, is distributed antenna system. This is where a hospital or a university or somewhere where they've got very large buildings, stadiums and sports arenas, and they've got really poor signal strength from the outdoor cellular antennas that the big cellular carriers operate. They want their guests and employees to have access to those networks indoors, so they build a DAS system specifically for that cellular carrier signal to get broadcast and transmitted indoors. So that's going to be using the cellular carriers licensed spectrum, and for the most part, that should be fine. They're using their own spectrum. We saw that one example earlier where there's potential for interference in the 2.4 gigahertz band, but by and large, they're separate systems and separate spectrum that can coexist pretty peacefully. Now, there are other technologies that don't coexist very peacefully. One of them is LTE-U. That is LTE in unlicensed spectrum. That's what the U stands for. And it's a way for the cellular carriers to use this unlicensed spectrum to enhance the capacity of their networks. So these, it's pretty remarkable what the cellular carriers can do today. They might have 150, 300 megahertz of spectrum, and that's it. And they're covering entire countries with just that much spectrum and with massive numbers of clients. It's really remarkable what they're able to do. So they are very hungry for new spectrum to add capacity, and so they've developed some technologies that allow them to access the unlicensed band. the way LTE-U works is that you stay connected in one of the carrier's license frequencies, and then when you need extra capacity, then you start operating in the 5 gigahertz unlicensed band. That's the same band that Wi-Fi uses. But the big sticking point here with LTE-U is there's no listen before talk protocol. There's a very primitive energy detect protocol that some would say doesn't do enough to share the spectrum with Wi-Fi. Wi-Fi was built for unlicensed spectrum, so it's very, very polite. If it detects any signal or other Wi-Fi operating, it will simply back off and not transmit until that channel is clear. So there was a lot of controversy when LTE-U was announced. Google, the Wi-Fi Alliance, even the New York City Mayor's office protested to the FCC about it, specifically around interfering with Wi-Fi. But that's LTE-U. LAA is license assisted access. It's kind of an updated version of LTE-U. It operates in the same band, but it does have a listen before talk contention protocol built in. So it's a little bit friendlier to Wi-Fi. However, you're still sharing the same spectrum, which, Wi-Fi is also very spectrum hungry, and it'd be better if we weren't sharing spectrum with other technologies. Multi-fire is another flavor of LTE that you'd find in unlicensed spectrum. This is not a cellular carrier technology. This was designed for private enterprises that want to stand up their own LTE network in the unlicensed band. So we don't need Verizon and AT&T. It's something we're doing all on our own. We're going to buy and deploy the equipment on our own. Again, it uses the unlicensed 5 gigahertz band, just like Wi-Fi, and it has a listen before talk protocol built in. So, not bad, but still, we're sharing the same spectrum again, which isn't ideal. So what's happened here in the US is we've come up with this, the FCC has determined that this part of the 3.5 gigahertz band called CBRS, the Citizens Band Radio Network, is going to be this new spectrum where we can operate LTE networks privately without carriers involved, and it kind of checks all the boxes. It's using spectrum that doesn't interfere with Wi-Fi. You can deploy it on your own. You don't need a license, although there is a priority access license that you could buy. And it does not have a listen before talk protocol, but that's fine because it's not sharing the spectrum with some other technology. So it actually ends up being more efficient because it's not worrying about that. So that's CBRS. There's a lot of interest in that, and a lot of we'll be hearing a lot about that this year. 5G is the next cellular technology, and we'll talk a little bit about that. It seems to have the most traction and the biggest use case in the industrial IoT space. But so we talked about, we just talked about a lot of these technologies. Again, coming back to this, this is an important takeaway here, and again illustrates why LTE in the CBRS band is such an advantageous way of deploying LTE in the enterprise, because there's no there's no compromise with your with the existing Wi-Fi network. So let's talk a little bit more about CBRS. I mentioned that there's a new license model here. The spectrum is partly licensed, two incumbents in the US. The Navy, wireless ISPs, and some satellite technologies have licenses to use the spectrum. In June of this year, the FCC will auction off the priority access licenses, PAL licenses. Those will be auctioned on a county-wide basis. And this will give some users of the spectrum priority access over unlicensed users to just a certain part of the band, not the entire band, which is helpful if you're trying to stand up something mission critical or run some really important business application. If you could have guaranteed access to the spectrum like in a pseudo licensed way, like the incumbents do, that could really make your network more deterministic, which is a word people like to throw out, but free from interference is the idea. Then there's the general authorized access. That is the unlicensed part of the band. It's 80 megahertz of spectrum that anybody can use, sort of just like Wi-Fi. Now there are some limitations about standing up LTE base stations in the CBRS band. You have to have a special license to do that, but you can hire vendors and VARs to do that for you and certify those base stations as you stand them up. And the way all this is organized is it uses a centralized system to manage spectrum access. So whenever you stand up a CBRS base station, it reports its physical location to a central database, probably run by the vendor that built it. And then that database says, okay, you're in Cincinnati on this street. And so this is the spectrum you can use. There's a PAL license over here, so you have to stay out of there. And the Navy doesn't have a lot of operations 1,000 miles away from the ocean out here. So other than that, you are good. That's really a nice system, because what we had in Wi-Fi with, say, DFS is sort of it's up to APs to sense other users, incumbent users in those bands that are shared, and get out of the way. And so there's so much uncertainty about whether you can use certain DFS channels or not, and sometimes you can, and then sometimes you can't, and it's really a headache. And there's a big false positive problem. So big headache, and there's hope that this will be a much better system. And something similar in 6 gigahertz will be better. So the CBRS band complements Wi-Fi really well. It uses unique spectrum, and it gives you access to LTE, which is something that's really unique in the enterprise. And what that's going to do is kind of give you some options. So LTE is a protocol that's built, from the ground up for voice. So if you have mission critical voice that you're using Wi-Fi for, maybe LTE might be something worth considering. There's a lot of use cases. If you have mission critical low latency apps that the business the operation of the business is really dependent on, put them in the CBRS band. And then you can use, then you can use the Wi-Fi network for everything else. So in a design like this, you've got, your Wi-Fi network, which is sort of the bulk of the data traffic. That's where it's going, and it's sort of best effort. Then you've got your CBRS LTE network, and that's where you're going to put those most mission critical assets that have to perform. So the two technologies complement each other really well, Wi-Fi and CBRS, and we'll see real deployments this year. We talked about the PAL licensing auction in June. And you can learn more about CBRS from the CBRS Alliance at cbrsalliance.org. The certification for CBRS LTE clients and APs, or they're not APs, they are, I'll call them base stations, is called OnGo. So if you see OnGo being marketed, that's CBRS LTE. So the other thing that the other cellular technology that's people are talking about a lot right now is 5G new radio. 5G, one of the biggest advantages of it is lower latency. Also, it has network slicing, which is a new feature not in LTE, which is hopefully designed to be deterministic in application performance by having more advanced quality of service applied to those applications. 5G is supported by the CBRS band. So if you were to deploy a CBRS LTE network, there is an upgrade path to 5G with that. And today we see the marketing hype around 5G just through the roof. I mean, it's just, if you're familiar with the Gartner hype cycle, you could say that 5G is at the peak of inflated expectations. So, as an engineer, I think it's really cool technology, but I also think, if we're going to think realistically about it, my advice is just to start evaluating 5G when the existing wireless technologies you have stop meeting your enterprise requirements, because LTE is an option. All the other protocols we talked about are an option, and many of them cost significantly less than 5G does today. But it's an important technology, and we'll keep an eye on it. Coming up in the US is the 6 gigahertz unlicensed band, and we expect to see rules perhaps here in the next 3 or 4 months issued by the FCC that will free up about 1,200 megahertz of unlicensed spectrum, which is fantastic. This would almost triple the amount of unlicensed spectrum available to Wi-Fi networks. So huge deal. It's already written into the 802.11ax standard. That's what Wi-Fi 6 is. So Wi-Fi 6 is ready, the standard at least, is ready for the 6 gigahertz band. And the Wi-Fi Alliance has created a term for that, Wi-Fi 6E. So the E is for extension, and that is extending into the 6 gigahertz band. So if you are looking for 6 gigahertz Wi-Fi 6 equipment, look for that Wi-Fi 6E certification. That's what you want. But again, the rules are not set in stone. The FCC under Chairman Pai has been very public about their intention to do this, and Chairman Pai has been very vocal about let's move. They want to give Wi-Fi more spectrum because they see it as such an important part of the economy. He's on Twitter actually and very active. I've got his Twitter handle there, and he, if you want to send him a note and tell him what a big deal more spectrum would be for Wi-Fi, I'm sure he would read it. He's a very active user, and any way we can influence him or let him know that we appreciate his efforts is worthwhile. So one of the interesting things about 6 gigahertz band, of course, there are incumbents there, but we're not going to repeat the mistakes of DFS in the 5 gigahertz band. There's going to be a coordinated access system called AFC, Automated Frequency Control, where if we, in certain circumstances, perhaps outdoors, for instance, if you've got a Wi-Fi AP there, instead of the DFS problem where it has to sense the RF and determine if there are weather radar or military radar or other incumbents, and then switch channels really quickly and leave all its clients behind, which it doesn't work very well. We'll have a centralized system where APs will report in with their location. Now, it sounds a lot like CBRS, doesn't it? And query a database and say, what channels can I use? The database will come back and say, you can use these. And then now we've got certainty. We know where we're allowed to operate. We know where we're not. We won't have weird interruptions that are, may or may not be legitimate. So that's going to be really great. And there's a potential that low power indoor Wi-Fi on the 6 gigahertz band won't have any requirement for AFC. That's all to be determined, but that's what's coming. So very exciting there. And of course, I've talked about this in terms of Wi-Fi. I'm a Wi-Fi guy, but all those other unlicensed protocols, you better believe they're looking at the 6 gigahertz band too in terms of new capacity and what could that mean for them too. So the key things to take away from today are, understand the spectrum usage. What protocols are operating where, and if they're sharing spectrum, create some enterprise policies about how that's going to look, right? If you've got Zigbee, what channels can you use? If you've got a lot of Bluetooth, well, do we need to rethink what Wi-Fi is doing in the 2.4 gigahertz band? And use the right protocol for the right application, of course. And I would encourage you, look outside Wi-Fi before others do it for you, because it's not just IT that is interested in wireless networking. Facilities groups, operations groups, biomed groups, they're all, they all go out and are talking to vendors and looking at deploying technology, and a lot of this is wireless, and it may be, using non-Wi-Fi technologies. So be prepared for that and get engaged in those conversations. And I would also put in a plug for the CWNP's new certification, the Certified Wireless Solutions Administrator. Really great entry-level cert that will teach you a lot about these new IoT protocols and give you a good foundation to build upon for your understanding of some of this. So with that, Don, I think I'll go back to you then.
Awesome. Thanks, Jim. Great work. Great presentation. We're just a minute over on time, so we probably have time for maybe one or two questions here. So I'll take care of some housekeeping notes while those of you who are going to ask questions are pecking away at your keyboards. We always get questions about will we share a copy of the recording and slides? Absolutely. All you need to do is email me. This is Don. I know you've all gotten emails from me, and whether it's replying to one of the reminders that you got for this webinar or something else, just shoot me a note and let me know that you want a copy of the slides or recording, and I'll get that to you same day. No problem at all. So let me get into these questions here and see what we've got for you, Jim. If you're having problems with cellular coverage in a building you own, do you need permission from the cellular operator to install a DAS or a small cell on their frequencies?
Okay. Yes. You need their cooperation to integrate with their network if you intend to expand cellular coverage, carrier cellular coverage indoors. And so there's a couple ways to do that. You could deploy a vendor-specific DAS, where they're going to come in and build out a DAS in your environment with their own hardware to support their own frequencies and customers. Or you could build a multi-carrier DAS. You'll probably spend a bit more money on that, but you'll be able to support all these cellular companies in your area. And then the other option for smaller environments, most of the cellular companies sell what they call femto cells. These are just small, usually LTE base stations that you can buy for a few $100 and plug in to your Ethernet network, and it's just going to create a small LTE network right there and form its own VPN connection back to the carrier's data centers. So that's a good way just to get a coverage in a smaller building without having to install a massive DAS.
Right on. Thank you, Jim. So I think that's all we're going to have time to get to today. Again, Jim, great presentation today. A lot of great feedback in here, as we always get. We really do appreciate the feedback. So thank you all for coming. For those of you who are interested in a product tour, no sales reps, no spin, every Friday at noon Eastern. If you go to go.7signal.com/tour, we can get you into a product tour. Invite your friends. We do take a look at both Mobileye and Sapphire on that product tour. So again, thanks everybody for coming. Jim, great job as usual. We'll see you all next week.
Thanks, Don. Thanks everybody for coming.